Good morning, everyone. In this video, I will be talking about domain analysis. So I'll be talking about domain class models and the domain state models. Okay. So during analysis, we build models and begin to understand the requirements deeply. This we have discussed when we were talking about the stages of software development process, object-oriented software development process. Okay. That thing we have actually discussed during analysis, we actually build the models and begin to understand the requirements. Okay. So if we really go back to the steps, whatever we have discussed in detail as of now, okay. So in the system conception stage, okay, so some users are basically generating the request, or say for example an expert or somebody, okay. So or an innovator basically generates those requests. He's actually talking with developers, managers, etc. to generate basically the interest, okay. And that's what we have discussed in detail in the system conception in the last video. And eventually we will come with this sort of problem statement. Okay. From the problem statement, once we have, okay, then we need to actually build the models as part of the analysis. Okay. We'll be conducting the user interviews. Okay. We'll be getting, say, for example, domain expertise, domain knowledge we will try to acquire. We will try to see the real world experiences. Okay. And we will also be studying the related systems. Okay. So you already have done a part of it during the system conception stage, but then you will be doing it in more detail, okay, and you will be eventually building the models by consulting with everyone and then later verifying with everyone. We also have discussed in the analysis model, we have two parts, which is domain analysis and application analysis. This video is specifically about the domain analysis. Okay, we'll talk about application analysis in the next video. So of course, once you build the models, you will have your class models, state models, and interaction models. Okay. So these are the things which we know, and we will be taking those things to the design stage. Okay. Let's only focus for the time being at this domain analysis. So the domain analysis is concerned with devising a precise, concise, and understandable and correct model of the real world. Okay. Real world you have to understand. Okay. So you have to remember this one. Domain analysis is basically targeting the real world. So the focuses on understanding the real world essence of the problem. Okay, so that's about the domain analysis. So basically domain model shows the static structure of real world system and organizes it into workable pieces. We have been working with these things. Okay. Say for example in the minor one, you have designed the model, class model for this for the bank. Okay. So that's a domain model. Most of the parts of it are domain model. Of course, there are also some application models. I will be mentioning those things, okay, when the time comes. But most of the components, classes which you have designed there are as part of the domain model. So you are actually designing the accounts, banks, okay, so the people in it, the employees, and then so on. So the domain model basically shows the static structure of the real world system. These static things will not change actually. Okay. The domain model actually describes the real world classes and their relationships to each other. Okay. How banks and accounts are related, accounts and the people, okay, say for example bank manager are related, the loans are related, etc. Okay. So these are the domain model, the real world classes. Okay. So during the domain analysis, class model actually precedes the state and interaction models. So in the domain analysis, okay, you start with the class model. Okay, then you will basically go to the state model, and the interaction model will not be touched that much. Okay, so in this domain analysis, why you do it is static structure is better defined, less dependent on the application details, and more stable as the solution evolves. Isn't it? Say for example, if you are developing any application, okay, so the core, the internal details, say for example the same example which I have talked about, okay, the bank, for that one you were designing the class diagram. So the bank, the different types of accounts, the accounts, okay, so the bank managers and then the bank staff and these people, Will not change. The structure is very well defined. And it is also less dependent on application details. Say for example, like the application details are something like you are doing the withdrawal, and then like say for example you are adding some money to it. These are all like application details which you will be discussing later. Okay, in the in the analysis, in the application analysis, you will be actually taking care of those things. But in the domain analysis, you will be worried only about the static structure, and this static structure is most often very stable. Okay, and it becomes really stable as the solution evolves. Okay, that's about the domain model. So as I said, like the domain model basically starts with domain class model first. Okay, and then like it moves towards domain state model, etc. So to design this sort of domain class model, perform the following steps to construct this sort of domain class model. So first you have to find the classes. Okay, we have already studied for the past almost like like during the unit 1, like almost we spent 5 weeks how to basically find relevant classes. Okay, say for example in the statement, like we have to develop a reservation system. A reservation system, and in the system conception you have come out with this sort of problem statement. A reservation system to sell tickets to at various theaters. Performances at various theaters. So that means like from this statement, like you can basically extract several tentative classes which are generally nouns. Okay. So for example, like reservation is one tentative class. The system is one tentative class. So the ticket which you will be using to visit a performance. So the performance are something like a dance or like an event or like something. Okay. At various theaters. So the performance is also a class, and a theater is also one class. Okay, this is just one example which I am trying to give you just to remind you how you are actually designing classes. Okay, so once you have the detailed problem statement from the system conception, you in the domain class model preparation, you have to first identify the relevant classes. That's the first step in. Then you have to maintain and prepare a data dictionary. Say for example, write a paragraph, a precise paragraph describing each and every class, okay, and you basically maintain it somewhere, so that like every time like you will be visiting this sort of class model, you should be able to understand what are the classes, because just from the names and the attributes and those operations which you see in the diagrams, sometimes they may not be obvious. Okay, you have to think in terms of like object oriented software development for the complete stages. Say for example, you will be visiting this sort of it would be an iterative development eventually. So you will be visiting these sort of class models again and again and again. Okay, assume like you are in the middle of the implementation phase. Okay, and then like you want to, due to some reasons, like you want to visit back, you should not be forgetting about all the things. So you need to have some sort of proper documentation about this one. So you have to maintain this sort of data dictionary, precise paragraphs describing each and every class. So of course, like once we have these classes there, okay, once we have identified the classes, okay, and maintained that description of all these things, all the classes, you have to find relevant associations. So these associations we have already discussed, like structural relationship between two or more classes. We should be able to identify proper associations, their association names, association and names. So we have discussed about all these things. Okay, so multiplicity and all the things like you basically have to identify. Okay, once you have identified the associations, okay, then you have to basically find the attributes of the objects, okay, and of course also the links. Okay, so you should be able to find all the attributes of all the classes. In the domain analysis, you have to understand like usually operations are not that much important. Say for example, going back to our minor 1 case, so we were designing the bank, okay, and when we think about the domain class model, okay, remember this domain class model. So basically like only the attributes are important. What were the operations which we were putting there? Of course, don't clutter the models with, say for example, all the getters and setter methods. Those all basically go into the implementation details. But generally, most often, like the classes will have the attributes. The operations are designed at the class model, okay, only when they are relevant. Say for example, like the withdrawal, and then like we had very few operations in that particular class model, if you really remember. Okay. Say for example, withdrawal, or like say for example, depositing some money, or like transferring between the accounts. These are the things which you will worry only when you are talking about these sort of application models. Okay, application analysis. In the application analysis as well, like you will have the application class models, which eventually will come to a single class model as the stages progress. But when you start with the domain analysis, you first try to find the attributes. Okay. Of course, operations already come in the next stage. Then once these attributes have been found, okay, so organize and simplify the classes with the inheritance. So then you basically try to find like where you can have the inheritance generalization, okay, and all the things, okay, so that like you can actually simplify the classes. Okay. You also verify as the next step, like you also verify access paths to the class model. Check if there are any classes which are lying in a corner. Okay, so check for disconnected classes. Okay, so in a class model, like if there is a class which is not linked with anything, probably you have missed some of the associations. You might have overlooked some of the associations. Make sure that it has not happened. Okay, so that's why like you have to verify the access paths through the class model. Okay. Once that step is done, okay, so then you have to iterate and you have to refine the model. Okay, a class model is rarely correct after a single pass. In single pass, you cannot come with an perfect class model, even if you are an expert. Okay, so for example, like if you find any deficiency in this sort of during this stage, okay, so you go back to the earlier stages and then like come back again. Okay, so start designing and identifying new classes and then like new associations, etc. Okay, so you come through all the steps again. Okay. Once, say for example, you have iterated several times and like you have refined the model, you can even reconsider the level of abstraction. Okay, abstractions actually make a model a little bit more complex. Okay, but can actually increase the flexibility and reduce the number of classes. Okay, say for example, like earlier, like we were thinking about, okay, say for example, going by the same bank example. Okay, so when we were designing the accounts and then like we were thinking about like say for example withdrawal and transfer of the funds, okay, and then like depositing the funds, etc. Okay. Of course, like when you want to really go at that particular level of abstraction, that is all perfect. Okay, so there is no problem with this one. But then like assume like the model becomes really huge. Okay, say for example you have designed the complete application. Okay, and then like say for example you are designing the application for the complete bank and then like taking care of all this sort of ATM machines, banks, okay, so sub branches, okay, so everything. The model really becomes large, pretty large. Then say for example you can think about much higher level of abstraction, stating like say for example you can think about just transactions at the high level. Okay, you don't worry about say for example all the transfer between the accounts from the ATMs to the bank accounts, etc. Because like most often like ATMs are not owned by a single bank. Okay, so the ATMs will basically reach different banks because you can insert several cards into a single ATM from a bank. Okay, so it is all pretty logical. So in the background, like there are a lot of other classes which you have to worry about. Okay, so then like the model becomes really larger. So you can put additional levels of abstraction. Okay, so that's the basic idea about this. So of course, like once all the classes are ready, try to group all these classes into packages. Okay, so that's also one of the important steps. Okay, with this one, like the domain class model will be ready once you have gone through all these steps. Okay, and you iterate over these things and you refine the model, like you will have the domain class model. Once you have the domain class model, you should start thinking about domain state models. Okay, some of the domain objects during while we were discussing about the state models, we have already discussed. Some objects actually pass through distinct states during this lifetime. during their lifetimes. The same thing also happens with these sort of domain objects. The domain objects also pass through these distinct states during their lifetime. Okay. Actually, most domain classes do not require state diagrams. Okay. Only a small subset of these classes actually require these sort of state diagrams. Okay. And these classes will have this sort of distinct states. Okay. And the state model can actually help understanding their behavior. Okay. That's why like we also need to have this sort of domain state models. Domain state model consisting several state diagrams. So to prepare a domain state model, you have to follow certain steps again. Okay. First, you have to identify the domain classes with the states. Okay, this is a complex process, but then like we have also seen this while we were discussing the state diagrams and those things. Okay, so we should be able to identify the classes that will have states. Okay, so once you have identified the states, okay, find and note the states of each of these classes. Okay, and then like give each state a meaningful name. So all these things like we have discussed when we were discussing about the state models in Java. Okay, but again like you have to do the same thing for the domain state model. So now we are looking at the stages of this sort of object oriented development process. Okay, so during this sort of domain state model, preparation of domain state model, you have to find all the states of each and every class, give each one a name, a meaningful name. Then you have to determine events that actually take an object from one state to another state. Okay, so we have to basically find out all these events. Okay, and when you are actually noting down all the states for each and every class in this step, it is not necessary to determine all the states before actually examining the events. See, every step in this sort of object-oriented modeling is an iterative procedure. And at every time, like if you feel like it is not comfortable, you go back to the previous stages and then like come back again. There's no problem with this. So sometimes like by looking at the events and then like considering the transition among the states, okay, you may have missed certain state before, which may become obvious now. Okay, and then like you will be adding those new states as well. Okay, once you have determined all the states and these sort of events, you will be building the state diagrams. Okay, for those respective objects and the classes. Note the states to which like each event applies. Okay, so right now like you have found out several states, several events. So note the states to which like each event applies. So and also like add all the transitions to show the change in state caused by the occurrence of an event. Only if you draw all the states and all the transitions, okay, along with all the guard conditions and everything, eventually you will have your state diagram. Of course, you should also worry about all these activities. Okay, so do activities. Okay, so all the things like we have discussed. Okay, so in the previous videos. So you have to construct proper state diagrams for those affected objects. Once you have these basic state diagrams ready, like you have to evaluate the state diagrams to make sure that they are complete and correct. Okay, you have to see like whether all the states are connected. Okay, in the class diagram, like when we were missing, like say for example, in the class model, in the class diagram, when you have a certain class lying in a corner, so that means like you might have missed an association. Okay, somewhere. Okay. But when you are thinking in terms of the state model, like if two states are not connected, okay, missing paths, actually sometimes means like you have actually missed a state. Okay, so go back, iterate again, and try to see like if any state is actually missing. And if you have identified such a state, like put it in the state diagram again, and then like complete this path for the particular state diagram. Because in the state diagram, you should be actually starting at this initial state and you should be going to the end state, isn't it? Unless like it is an iterative process. So you have to refine those things. Okay, so you have to evaluate the state diagrams and then like you have to basically refine them for their completeness and correctness. So when a state model is complete, it should accurately represent the life cycle of a class. Okay, remember this one. Then comes the domain interaction model. So we talked about domain class model and the domain state models. But domain interaction models, okay, they are seldom important. Okay, so interaction models are rarely important for the domain analysis. I have been giving the same example. Say for example, when you are purely thinking in terms of the domain model, okay, so that is like the real life system of a bank or something like that one. You are not worried about how you will be interacting with the system and all things. So the interaction models, say for example, the use cases, the sequence diagrams and those things are not directly important during the domain analysis. Okay. So during the domain analysis, the emphasis is on the key concepts and deep structural relationships, not the user's view of the system. Okay, or not the user's view how he is actually looking at these sort of structural relationships or the concepts, or how he will be interacting with those things. Okay, interacting with those components. So interaction model, as I mentioned, like interaction model is more important for the application analysis. Okay, and while preparing this sort of application model, which we will be discussing in the next video. But remember one thing, it's always iterative analysis. Okay, most analysis models require more than one pass to complete. Okay, to understand a problem with all its implications, you must address analysis iteratively. Okay, so waterfall model, okay, will not directly apply to this sort of object-oriented development process. So if you want to go iteratively, like prepare the first approximation to the model, okay, and then you keep on iterating and refine the analysis model, okay, as your understanding of the complete system increases. Okay, that's how you will be actually iterating through these things. Even for the domain analysis, okay, so you'll be iterating. Say for example, you have prepared the class model, you have come to the state model, and during the state model, like you find certain problems, and then like say, you may come across a situation where you may have to design a new class as well. Okay, so that means like you are going back to the class model, domain class model, and you are trying to add those additional classes, even though you have gone through several iterations at the class model itself. So regarding the reference is concerned, this is the excerpt from chapter 12 of object-oriented modeling and design with you, Michael Blaha and James Mbaku. Thank you very much for your attention.